All right. I'm going to talk a little bit about something completely different, such as the implementation of cultural heritage data inside the INSPIRE Directive. We're going to start talking a little bit about protected sites, for cultural heritage are part of it, and then describe the application schema that we propose here, to end with a brief conclusion. So as you may all know, protected sites are part of INSPIRE Annex I, and its definition includes cultural heritage. But the protected sites data specification takes them into account, but there might be some adaptation difficulties that we want to overcome with this application schema. There are, of course, some difficulties regarding cultural heritage data themselves, for there is a big lack of standardization, and at least in the Spanish case where we have worked, there is a heterogeneous integration into information systems. Some regional administrations responsible for the management of this data have built their information systems in different ways, and some may not have built anything at all. So we can regard this as an opportunity if we look at it in a positive way, because maybe it is the time to build some applications, some information systems in an interoperable way inside INSPIRE. There is also, we have to bear in mind that cultural heritage is a broad concept that includes a lot of things. I have written some of them, such as a church, a wall, a pilgrim's way. There are many different things are cultural heritage, so it's a complex matter. There are also some troubles regarding cultural heritage as geographical data. There's a lot of georeference data, and when we have them, we don't have the necessary quality assessment, so there's a big task to undertake in that sense. And there might be also some issues regarding the adaptation of the thematic scope of this data inside INSPIRE. So we think it was necessary to build an interoperability schema. This work has been done inside the Spanish Working Group for Spatial Data Infrastructure that is responsible for the implementation of INSPIRE inside Spain, and is set up of different subgroups. One of them has been the Thematic Working Group on Cultural Heritage. So we want to acknowledge everybody who has been working inside this group and helping in the development of the schema. All right, so let's take a look at the main features of the application schema. First thing I want to convey is that we try to build an application schema generic enough to embrace all kinds of these heterogeneous georeference cultural heritage data, extendable to allow data providers to build their own systems, and of course interoperable, which is what we're talking here about. To achieve interoperability, we have used the main ISO standards regarding geographic information, and also the INSPIRE documents that are relevant to our model. Okay. But there's also another point to take into account, that is in interoperability among heritage data themselves. So in that way, in that sense, we have used the ISO, the only ISO that is searched for this, that describes cultural heritage concepts in an abstract way, which is the Conceptual Reference Model, CIDOC, and also the Dublin Core metadata initiative for documents associated to cultural heritage data. We don't claim conformance with these ISO standards, we just have used them to shape our model, but just to allow that data providers who use them to integrate their data inside our model. So this is an overview of the class diagram. It might be big, but it's not as much. All classes depicted in white and blue are protected site classes. Our schema is an extension of the protected sites data specification, and the extended classes are depicted in yellow, and also some modified classes. It has two main parts. One is the legal part, and that gathers all information on the legal nature of the protected site, and the other one is the cultural entity part. This is the part of the real-world future. In other kind of protected sites have their real-world phenomena developed under Annex III, any theme of Annex III inside the INSPIRE, such as habitats and biotopes or species distribution, but there's no specific theme for cultural heritage. So we thought it was a good chance to offer a minimum schema for this kind of questions. So this is the protected site application schema. This is the main class that is protected sites, has protected site simple and full. There are two schemas inside the protected sites data specification, the simple and the full schema. All extensions are to be built on the full schemas, natural, so is what we have done. And as you may see, all attributes are regarded voidable, except a geometry and an identifier. What we have done is we have we added a new class that is called Protected Heritage Place. It's built as an extension of the main class of protected sites, so it inherits all the attributes and adds 3 more attributes. Also makes some of the protected sites attributes compulsory through the use of a constraint. In the end, what we have is that the legal part of our schema is described by this class. It's a future class that has 13 attributes, among such things as identification, their spatial nature, life cycle, that is also inside the INSPIRE data specification, and mainly legal and administrative issues. Some code lists are provided by INSPIRE to fill with the nature of the kind of legal figure that protects the cultural entity in this case. And when possible, they have been extended to include the nature of the cultural heritage data. We also added a new schema for including all Spanish protected cultural heritage places that are called bienes de interés cultural. And there are also some code lists provided by INSPIRE to specify the reason why the site is protected. And here we have in the INSPIRE data specification schema a cultural tag that should be filled for all cultural heritage data, we think. And we also added a new schema to provide information about the kind of cultural heritage place, such whether it may be archaeological, architectural, or ethnographic, the 3 main classes, although it might be extended to include more classes. We also add relations to gather some information that is relevant inside the legal definition of cultural heritage places, protected heritage places. That one is the containment of one place by another, because this is usually acknowledged in the documentation. And for example, a historic landscape may have other cultural places inside, such as churches, archaeological sites, whatever. There are also a relation between a protected site that has a cultural entity inside and its surrounding. That is also a protected site, but may not have any cultural entity inside. It's just a surrounding area that is protected too. And to go on to talk a little bit about the real-world entity protected inside by this legal figure, we use the protected entity type is an attribute designed for inside the INSPIRE data specification. And from here, we propose another class that is cultural entity. Cultural entities are the result of human action that are regarded as heritage. They are arranged according to the CIDOC CRM conceptual reference model, as I said at the beginning. And the only attributes we propose to fill are 5. And a name that might differ from the name, the same as happens with the geometry, it might differ from the name of the legal figure, and the geometry might be different too. Also, an entity tag to express what kind of cultural entity we're talking about, for example, a Baroque church or a data mining Neolithic complex or a rock art cave, whatever. And also a chronology that is very important for this kind of protected sites. So I'll talk about chronology at the end of the slides, because now I continue with the schema. We also wanted to allow data providers to break down the data sets into as many parts as they want. All of them would be cultural entity themselves. For example, we can model an archaeological site just as one cultural entity, but we can also model all of the buildings that are inside these sites, all of the walls, houses, stratigraphical units, whatever, and they would become cultural entities as well, related to the main feature. We take into account the main distinction of cultural entities, that is between material and non-material entities. Material entities are all those that have a tangible existence. Everything you may think of now, surely, is a material entity, and non-material entities are those kind of protected things that whose existence depends on performance, such as a traditional feast, for example, that always takes place in the same location. So it also has a spatial nature, but it's not there. It depends on performance. Material entities are subdivided according to the CIDOC conceptual reference model too, into human-made objects, human-made features, or natural features. I want to extend a little bit too much on this. And also, we may also have samples on a material entity. For example, we may get a piece of charcoal from an archaeological site and then have an analytical result that could be a radiocarbon date for that piece of charcoal. So we also thought it was interesting to model this aspect of cultural entities. And finally, we have also gathered documents according to the Dublin Core metadata element. We just shaped the model according to the main subclasses of documents. And to finish with this part of the cultural entity, just have to talk a little bit about the chronology. That is very important for us, but we found that ISO, a geographic information ISO, was good enough to express all the chronology a cultural entity might have. It is the ISO 19108 that allows us to regard chronology of cultural entities as a timeline that starts by the creation of the cultural entity and goes on till today. And it's marked by milestones that we call events here, that might be of creation, occupation, abandonment, maybe reoccupation, modification, restoration. And as the ISO 19108 expresses all these things by using nodes and arcs that are instants and periods, we think it's a good schema for us to use. So to conclude, we try to offer an interoperable schema. It's based on the Spanish case where we have worked, but many things we hope that might be useful for other cases, for other use cases. And we hope this work might encourage data providers to provide the data according to SDIs and to OGC standards. And there are indeed some applications that are already being built based on this application schema, although they are still at a very early stage of development. They are based on archaeological data sets mainly. And that's everything. Thank you for your attention.
Thank you, Carlos, for this interesting presentation. Oh, there are already 2 questions from audience. Can we have a microphone, please? Yes, they are in the last row, and okay.
Thank you. I have a thematic question. Your approach regarding the chronology reminds me to CIDOC CRM. Did you consider this, the CIDOC reference model while developing the application schema?
Sorry, I didn't understand you. The CIDOC CRM has been, well, there are only 3 classes.
Already provided GML application schema or not yet? Annex SD, for instance, just to produce some GML data?
No, we haven't gone down to that detail yet. This is just a proposal of an interoperability schema.
Okay.
And it's still under discussion, but the main features are already right. So we only have the application schema yet in modeling UML, okay. But we haven't gone down to the GML.
Thank you.
Some more questions, maybe? Doesn't seem so. Okay, I propose to move on. So.